Hello, people in the world. It's me again, DOS EMU. I want to discuss something. I always have something to discuss. I always have something to say. What a douche. Alright, so I want to say something. I am not a fan of virtual machines, period. Period, period, period. Okay? Now, I understand that it's not common to actually have junk sitting around that you can actually put stuff on and whenever you feel like it, okay? But I am not a fan of virtual machines, okay? I do have a few junk old computers that, are good for things and all that stuff like that. And a lot of people do things on virtual machines, right? But I have a problem with functionality. Functionality. Can we say itty? Functionality is limited, okay? Um, on certain things, okay? With virtual machines, right? I used to use VMware. VirtualBox, okay? VirtualBox, and it's not crap. It's probably settings. It's probably this or that. But I'm going to tell you for a fact that I have had more luck on putting software and operating systems on physical machines than in virtual machines as far as a test environment. Alright? And if you guys watched my Linux from Scratch toots, that was hell to do on a virtual machine. I couldn't do half the things that they wanted me to, according to the book. And F-Disk wasn't so bad, but it's a virtual machine. You know what I mean? Period. Now it's good for things. It's good for running operating systems that are, not complicated, or just plug and install or click here and once and go away, and when you come back your operating system's already installed. It's good for stuff like that. But I do believe when you get down at a low enough level, things start to break down. Okay? Period. Now, DOS EMU is no exception. Okay? What we're using here is no exception to breaking down and not doing things the way that they should be done. Okay? For instance, this is a basic feature in which this here, alright, hey, maybe I'm doing it wrong, I don't know, alright, but this here, this fill command, F for fill, okay, which I can fill certain segments. I can fill certain data segments in here with zeros or ones or whatever I wanted to, alright. And in the last tutorial, you guys see me fail miserably. And the basic syntax is fill with your range. If I want to say fill from 100 to 120, okay, with zeros. Alright, well, I get errors on this. And there's really no reason why I get errors on this. On the machine that I actually have DOS installed on, which is Intel Pentium 3 with 900 megahertz, or maybe it's one, I think it is 1 gigahertz flat. That 1 gigahertz processor, alright, I got no problem filling sections from 100 to 200 with straight zeros, okay? But in this emulator, I have had problems. I don't know. For one, I will tell the truth and say that DOS is crap, okay? Well, why are you using it? You know? Because it's what we got, what I got, alright? And it is crap. It's a shitty operating system. And think about it, if you put a shitty operating system into a VM, what's going to happen? What's going to happen? You know what I mean? VM's already restricted to a certain level, okay? So is the operating system at a certain level, so it's like, where do you get off? Okay? So that's a problem. I don't understand why I cannot fill certain sections that I want to with zeros, but that's the case, okay? And that sucks. Now, let me type in debug again, and there's also another command that you can use to change certain segments at a time, okay? And that's enter into, let's say, data segment, 100. Okay, right now by saying enter in data segment 100, we're actually changing the value is here. Okay, F6 is currently here. Now it's prompting us to say what do we want to put in place of it. So we want to change F6 to 77. Okay, enter. Normally in a DOS machine, I have DOS 7.1 installed on my other machine. Normally when you do that, it doesn't pop you out back into the command structure area. Okay, it'll keep you going. So after F6 is changed, then it'll go on to the next thing, which would be address at 101. Okay, then you can change address 102, then you can change address 103, 104, 105, 106. You get the idea. Okay, but with this emulator, for some reason, it decides to pop me all the way back out. So then I would have to say something like enter data segment 101. It's currently 0. Let's change it to 44. Okay, now I'm not going to write, but I am going to say dump. Okay, now you see that we dumped it. We see no change because when we dumped, it just kept on going with our addresses. So let's say dump at address 100 again. Okay, and address 100 we changed to 77. Okay, and address 101 up here we changed the value that was in there to 44. Okay, and that's cool and that works. But guess what? After an amount of time when you're doing all this, something happens where sometimes it just does not respond. Alright, or you get error. Okay, or it just does not do what you think it's going to do. Okay, I entered these two correctly and I'm surprised that actually happened, because on the last time I tried this, I entered this one and that went through. I entered this here, I changed this value here, dumped it back at the same address to look at my data segment. My data segment never changed. Okay, and it's not a problem with syntax, it's not a problem with me putting it in, it's not a problem with anything else like that. It's a problem with the daggone operating system on an emulator. Okay, so these are some of the problems that you may run into. There's some unexplainable errors that you will run into. Okay, you may run into if you're using an emulator, even if you're using it on a physical machine itself. That's the thing that really gets me. It's why in the hell this DOS sucks so bad. And there is a good explanation for that. I told you about the jump thing before. Okay, this means this is jump. You'll see this code quite often. You see it right here, jump. Okay, means to jump to an address. Okay, means jump somewhere. Okay, for instance, F48, FE48. Is there an FE48? I don't know. It's in there somewhere, or out of here somewhere. It's in the universe. Okay, somewhere in the realm. But the jump command, which we'll go over maybe even now, or in a little bit, in a short while in this video. The jump command jumps you to a certain place in data or location in memory. Okay, now the thing that struck the hell out of me was that let me open up an editor, get some color on the screen. The thing that struck the hell out of me was, oh yeah, this is good. New, open, new. How about can we cancel this? Hey, look at this, guys. Oh, okay. Thought I was having problems with my editor. Alright, the thing that struck me was with the jump command. Jump will take you to another address. Okay, so pretty much what's going to happen is you're going to say you're going to be at this address here. Okay, this is going to be an address. Okay, and you're going to be la-di-da and everything else like that. Okay, you hit say address 110 now. Okay, la-di-da-di-da-di-da, and what happens is you'll hit a jump. Okay, and that jump, you're going to tell that jump to take you to another address. Okay, say if we wanted to tell that jump to take us to 130. Okay, so then now when we hit that jump in succession like that, we'll now be located at address 130. Okay, let's make it a little bigger so it doesn't get so complicated. 150. Okay, first of all, we're going to start our code here. You know, move string, blah blah blah, whatever like that. But as soon as it hits this jump, As soon as it hits this jump here, this jump tells it to jump out, skip over. It's going to skip over 120, 130, and 140, okay? And it's going to shoot right to 150. And at 150, what it's going to do is it's going to continue to go on from there, okay? That's pretty much what a jump does. And I'll show it to you better in another tutorial. But my problem is this. For some unknown reason, well, at the time unknown reason was, I had a program that ran from, say, 100, okay, and then it went to 110, blah, 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 read data, and then it's supposed to hit this jump. And the jump was supposed to go to, say, 150 or so, like that, okay? Well, let's make it, say, 160, okay? So, now we have to change all this because I'm an idiot. Alright, so, it took a jump from 110, okay? It was at 110, blah, 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 and then it was supposed to jump from 110 to 160, and then at 160 it would continue on. Alright, well, normally, if you think about this, this is 16 times 4, it's bytes. Alright, it's bytes of data. There's a gap of 50, I don't know how many bytes it is, alright, but it's bytes. It's not megabytes, it's not huge amounts of data or whatever like that, but I couldn't jump that far, okay? And I ran through the code over and over again, and I kept getting the same error. And with DOS, I don't know if you've noticed or not during syntax, but with DOS, the only thing that you get with DOS, is that shit. Alright? That's all you get. It doesn't say error, jump too far, okay? It doesn't say anything like that. You know, it doesn't say error, DOS is shit. It doesn't say that, okay? You just get error. You have no idea what the hell the error is. Alright? I understand I'm a computer guy and I'm supposed to figure this out, right? Yeah. But it does not give you any input. Well, I did figure it out, and it was stupid. It was stupid. For some reason, I would be at address 100, and then in a natural progression, it would go down to address 110 after it read its 16 bytes, and then I wanted to jump from 110 out to 160. Can you believe that it was so dumb as even 10 bytes difference? Okay? And after that, after I hit the 10 byte difference, I could go ahead then and I can continue on out. It was only 10 bytes of difference. That's 80 bits. Right? I guess. You know? It was within like 10 bytes of difference, which made no sense to me at all. Okay? And also too, jump can also be said, jump if not 0. Okay? That means that when you're reading data, alright, naturally you kind of want to throw a compare statement here, and you compare, you want to compare, say, what's in the AH register with, say, 99. Okay? 99 will be, the AH register will have a number in it. What number? Say, who knows, okay? It doesn't have 99 in it yet. Alright, but you want to compare with, say, the AH register that's holding a number for you with the number 99, okay? And basically, you're going to read your code. It's going to naturally go to 110, how it does in our natural state. Alright, then you want to jump to 150, okay? Which is possible now because I moved it 10 freaking bytes, okay? And then at address 150 now, you're actually going to be at address 150 with the compare statement, okay? At address 150, we're going to compare what is in our AH register with the number 99, okay? Then after that, it's going to fall out and it's going to say jump if not 0, okay? Or jump if equal to, okay, equal to what? If it equals 99, okay? Jump if, this is not a bit of syntax, jump if AH contains exactly 99, okay? Jump if equal to. But with a jump, you have to tell a jump where to go. Jump if equal to 99, okay? So let's say jump to 200 if it's equal to 99, alright? Now, the question is this. With DOS, with machine code, with anything you need to allocate memory to before you write to it, basically, when we're doing this in machine code, we need to first, we need to know how much memory we need to allocate to something. Say I'm going to write 300 bytes to something, okay? And then it's going to go. And then I got to enter the code here, okay? Because I already allocated memory for it. I carved out a slice of the pie to throw the code, and I'm expecting my code to be somewhere around, say, I don't know, 300 bytes actually is a huge amount, alright, for an assembler code. But it's a bloated amount for a Hello World program per se, not for assembler code altogether, alright? You do have big assembly programs. But 300 bytes is pretty large, and I need to allocate 300 bytes to it. And then, I need to tell the operating system to give me 300 bytes of space to work on. And then I need to throw in my code, okay? Which may only be, say, 230 bytes or so like that, alright? So 70's left over, okay? No biggie. Well, with this thing here, if I'm at address 150, and at 150 I do a compare statement to compare the contents of AH with the number 99, and jump if not 0, I'm going to say jump if not 0 to 180, right? And then at 180 I'm going to have some data here, okay? That's going to be at 180. So it's going to run down, hit 150, it's going to do a compare statement. If it's not, let's say not 0, let's say jump if less than, jump if less than, jump if less than, okay? JL, jump if less than, I think that's right. If it's not right, it's pretty darn close, and it doesn't matter right now. This is this example. I'm at 150, I do a compare statement to check my AH register with the number 99. If it's less than 99, it's supposed to jump out and do something down here, okay? It's supposed to do something down here in the 180 range, okay? But if it exactly equals 200, okay, or if it exactly equals 99, then it's going to jump to address 200. And this is the problem that I have. At address 200, I now have to say more data, okay? Because DOS sucks. It will not let me jump from 150 to 200. Alright? It'll let me jump from 150 to, say, 185, right? Which is too tight for me, because I have 5 bytes of data that I have to say here. And it's not that I'm saying, you know, echo out, you know, sorry your number's too large or anything else like that. What happens if I wanted to take this and keep it going somewhere else? Okay, what happens if I wanted to take it and say, you know, move a new number in and print a string or some crap like that? You know, what happens if I wanted to do that? Well, I have to be pretty damn precise with my jumps. With my jump equals, with my jump less thans. You know what I mean? And that to me is just retarded. And the only thing I get back as a failure, the only thing I get back is error. That's all I get. You know? So I don't have that problem anymore because I know what's going on now. And I'll tell you that in a second. I'm sorry I have to vent and rant about an operating system it seems like I'm forced to use. I'm not forced to use it and all that, but I do notice the ironies, and I appreciate Linux more, and I cannot wait to learn assembler so I can go over to Linux and practice and do more assembler. Alright? There's just no help. There's just no help for Linux assembler like there is DOS. Okay? So listen to me rant. Laugh at me. It's funny. Okay? Because, you know what? I bet you you're going to experience this, and you're going to sit there and you're going to rack your brain just like I did. I hope you do. Alright? Because that means that we can't stay at DOS. There is a light. We got to get back to the other side of the river, dudes. Alright? But, like I said, it can't take this big ass jump. Alright? Let's put this back. I mean, and it's not even the tolerance. The tolerance is not, it's not that big. It's 20 bytes of difference, say, okay? 185 would be correct, you know? But 186 is a fail, you know? Like, how the hell are we supposed to guess this? You know? I'm not a DOS guy. I figure 20 bytes would be a sufficient enough range for a jump. Alright? But what it does is effectively it squeezes the hell out of where your code's gonna land. Sometimes you don't know. Sometimes you don't know where your code's gonna land. And that really sucks. Okay? I'm gonna tell you what it is that, and this goes really deep, and some can call me a complete idiot for this. I don't have a computer science degree. I used to be a carpenter until the economy tanked and left me sitting at home with a bad back. Okay? This is what happened. Now, when you hit these jumps, there's something that, let me skip down here and block that out. I'm gonna say there's something called a frame buffer. Okay? And what it does is it takes certain amount of memory, okay, and makes it so you can access that. Okay? And with the Linux operating system, it's huge. It's huge. It's efficient. Okay? Because the way that it reads is, if you need memory, it'll give it to you. If you need it, you give it to you. Give it, need it, give it, give it, need it, give it, give it. Okay? But with the way that the DOS operating system works, which is pretty damn shitty, it throws at you, say, 200 bytes of memory right off the bat. 200 bytes of memory. You do whatever you need to within that 200 byte range. Okay? Now, when you're roaming around in the dark and you don't know where your address is going to line up, and you're trying to learn something about this, 200 bytes is not that much tolerance or anything for failure. Okay? And it would be nice of them if they ever were to have done some type of thing where they said error, like in Linux, error, shit's too big, man. Okay? But they don't. They just throw error at you. So you don't know if it's syntactical error, you don't know what kind of error it is, and it makes no sense to you, and you rack your freaking brains, okay? Especially if this is the problem. If your frame buffer exceeds by 1 byte on a jump, it'll just give you error, just like everything else. It doesn't matter if it's syntactical error, it doesn't matter, you know, whatever. It'll just give you an error for 1 byte tolerance difference. Bullshit. Bullshit. Okay? That's the stuff that you're going to run into. That's the stuff that I ran into. And say this. 200 bytes of memory access. It's not exactly 200 bytes. I don't know if it is exactly 200 bytes. But I tell you one thing, like I said, when I ran into something where I had to jump from address 1, okay, which only equaled, I mean really, seriously, only was in a tolerance within 30 bytes. 30 bytes of difference, okay? I wanted to jump from this 30 bytes and then I wanted to jump to another address that was like 30 bytes away more, okay? Okay? Now, I would get error, and it made no sense to me at all. I was doing everything exactly the way that it should have been done. I actually mimicked the tutorial that I was on, okay? And I got an error when this guy on the toot did not get an error, okay? And the distance of what I call a frame buffer, it's just retarded, just retarded. Like I said, DOS seems to throw at you a chunk of data, 200 bytes, okay? Pretty much whatever you see on the screen. Ooh, escape gives you an arrow. Word. I can use that. Let me save this as junk.txt. Okay. Remember again to which I had to figure out too, which is a bunch of bullcrap, how to use this editor. Control Alt brings up a menu panel when you push a down arrow. Okay, and you get stuff here, and we'll just say exit. Okay. Now, debug. Okay, let's just say dump. Okay. Now, literally, this is no kidding to you. This is only 70 bytes of data. This is a 70 byte span. Okay. Now, when I was on even my hard machine, my physical machine, it would only spit out at a time, I don't know, it might have spit out this much. I don't know why this is only spitting out 70 bytes, but it might have just spit out this much. Okay? Even here, we would say from 00 to F0, that's 160 bytes. Okay? It's 160 bytes flashed to the screen, alright? Or that's allocated to memory right now. So if we were to do something here and say jump from 190 to 02A, for some ungodly reason, you would just get error. That's all you would get. Okay? Has to deal with a frame buffer. Alright? Nobody told me that. I assumed that. And this is how I assumed it. Clear. I will say this. Linux we know is God, right? Great. DOS, as you know, sucks. Alright? Now, also too, the Linux file system writes in a different manner than the Windows file system does. Okay? With this file system, what we're on now, I think it might be a I don't know if it's a VFAT. FAT32, FAT16. I'm gonna say a FAT16-ish. I know normal DOS is like a FAT16. Or a FAT32. Okay? And that's a different file format. FAT32s came out. I can't have a new line. Kidding me? FAT32s came out back in the day, or FAT16s came out back in the day, and that was a different type of file format to write to the hard drive. Okay? Not every computer writes to a hard drive the same way. There's better ways. There's worse ways. Windows decided to be a worst way. FAT16 was a type of file format. Okay, so is a DOS, maybe not. Let's say MS-DOS, was that a format? Maybe, I don't know. Alright, I'll show you real quick. This will be no biggie. Let's exit that damn thing. Let's say fdisk. Okay, and let's say something like fdisk L for list. Now let's say fdisk dev sda sd. Let's do sda1. Okay, print t. Ooh, I can't believe I forgot how to use fdisk. L for list. Yes, perfect. Windows 95 in a FAT32 format. Okay. You can look up here, you see a FAT12. The FAT file system was a way that it wrote to a hard disk. Okay. We use our 83. That's the way that we write to hard disk. Okay. and that's not extended, but that is ext 3 file format, ext2 with a journal format. Right, ext4, I'm not sure if that's still considered 83, but I think it is considered 83. Okay, NEC DOS is 81. NEC DOS, or maybe no, maybe it's back. Yeah, it's backwards. It's 24. NEC DOS, maybe it's like Nintendo. You know what I'm saying? All right. Commodore has their own kind of, which is definitely not going to be in here. I don't think so. But you know, blah blah blah. Here's another DOS file format, F2. Okay. This is a FB VMware VMFS virtual machine file system. Blah blah blah. Well, there's a FAT12, FAT16 less than 32 megabytes. Okay. FAT16, I guess more than 32 megabytes that I can have to write to at a time or whatever like that. Right. FAT32, LBA is logical block addressing. It's a different format. Well, these are file formats. This is the way things write to hard drives. Okay? NTFS, number 7, HPFS. HPFS, by the way, is the way that Macs write to their HFS. HFS, I don't know if HP, but HFS is the way that Macs write to their file system. So if you want to format something for a Mac to be used on, which that's a whole nother topic about hiding data and not incorporating anything else in the world. Shadiest damn company that I've ever dealt with as far as the computer goes is Mac. HFS is the way that they do their stuff, but NTFS is the major Windows file format. Right? It's not a DOS format, but DOS is on newer Windows machines, and they came out with, this is more recent than the FAT formats. Okay, but there are different file formats. Different file formats write to the hard drive in different types of ways. Okay, and with let's see, edit junk. With the DOS file system, like I said, it seems to have some type of frame buffer. Okay, that cannot exceed a certain amount in time or of space. Okay, but the frame buffer they give you is like some stupid ass amount. Okay, so whatever you're writing at any time exceeds that frame buffer, you're just going to get the unknown error. Okay, and you're not going to get an exaction Y. Now, the NTFS and the Windows FAT file system, when anything Windows affiliated, the difference between the way that they write to our hard drives and the way that Linux writes to a hard drive is totally different. If you have been a Windows user, you will definitely know the things I'm going to say. Linux is great. We all know that. And it's not great because it's free, independent, a rebellious underdog, or anything else like that that like 30 million people contribute to. Okay? It's not great because it's a communal type of thing. It's great because it's efficient, it works, and it's solid. Okay? And partly because of all those people that contribute to it. Well, Windows being all bottled up and everything else like that, with their maybe 10,000 people staff on the file system, are constrictive and unproductive. And they cause headaches to people. Headaches that do not need to be there. Okay? Now, the way that Windows writes to a hard drive is exactly, this is no lie, exactly how DOS writes to a hard drive. It throws up chunks of crap. Windows NTFS might be a little bigger. Okay? But it throws chunks of data at a time. It'll throw this at the wall. Alright? That's a great analogy. You take a hand of mud, throw it at your wall at an alarming rate. Alright? One chunk. Take everything not specific at all and just throw it at the wall. Okay? And then what you have to do is later on, that's why you have to defrag the hard drive, or you have to defrag a hard drive with an NTFS partition or a Windows operating system. You have to defrag this damn thing. Alright? What is defragging? Well, it's kind of like getting all the air out, right? There's air all up in your line. Alright? It's not solid, it's not compacted, it's not written in that type of manner. Alright? You have to defrag that hard drive to bring it back to a solid whatever. Okay? And one of the reasons why you have to defrag it, it's in the file, the way that the operating system writes to disk. And the way that it writes to disk is just throws a whole bunch of crap at the wall. Okay? The same thing with DOS. DOS just throws a whole bunch of crap at the wall and expects you to deal with it. Okay? So you got 20 megabytes of memory access. Okay? Which is restrictive. And it just throws it at the hard drive. Alright? And they say you have to compress it and whatever else like that. No, you have to rearrange everything that's been thrown onto the daggone hard drive. Alright? And partly because of this buffer. Now, exit. Yes. Okay? Now, when you go ahead, debug. Actually, I should have cleared it first. Clear. Debug. I could be totally wrong, but this is exactly what I'm getting. Okay? Right now, this much memory is thrown at you right now. This is your memory to deal with right now. You could change location and go somewhere else, but right now, all this memory is being accessed right now. It's a draw on your system. Okay? It's kind of like drinking from a fire hose. Alright? You don't need all this stuff here. Okay? And like with Windows, when you write to something, you have to allocate memory. Yes, this is true, but the way that it writes to it is you say 1 and then you know, you go in and you get 2, 3, 4, 5, 6, 7, 8. Alright? You want to think of it maybe as a loop. Okay? Think of it as a loop. Okay? And this loops, say this thing loops every couple of seconds. Okay? And whatever you put down, alright, the kernel comes back around and loops it back in. Okay? And it loops it at a proficient rate, and that's how you get an even symmetric layer of data on your hard drive where you don't need to defrag it. Say, how can I say this properly? Say if you have a loop, say a spinning wheel, okay, and you toss something into the spinning wheel, or maybe that's a bad analogy. It loops. Like say if you had soon as you put it down, the kernel comes back around on a loop, comes back around on this revolution. Okay, comes back around on revolution, and then what's it do? It goes right ahead and it lays it down, and the next one comes and it lays it down, and it lays it down. Okay, it keeps coming back, it keeps refreshing for data. Now the Windows operating system refreshes for data too. Yes, this is true. Alright, and the file format, I'm sure, refreshes data too. Yes, this is true. But with the Windows system, it takes smaller chunks of data, I think, and just lays them properly how they should go. Okay, no defragging, none of that crap. Okay, now with the Windows OS and affiliates, alright, the way that they do things is they expect you to want this much data. Okay, and when you don't use that much, but say you use this much here, okay, this whole block of shit gets thrown at your hard drive. Okay? That's what happens. This whole block of crap gets thrown at your hard drive. Okay? And the whole block of crap gets thrown at your hard drive every, who knows, 100 milliseconds maybe. You know, it doesn't matter how long, but it just gets, the whole crap, the whole load of it gets thrown at your damn hard drive, okay? You only use that much, but this whole thing gets thrown at it, okay? So what's going to happen when you need to come back and get this data? Alright? You're going to need to defrag these 3 areas that you didn't use and these 3 areas that you didn't use, and that's going to take up like your whole Sunday afternoon and everything else, and you're going to have to like freaking schedule this and all kind of shit. Alright? But that's what happens. And the reason why that happens is the way that Windows does things. All this here memory is now present to you. This is a big chunk thrown at your face. You can edit this chunk, okay? But the problem is you can't jump from 120 address down to 200 address. Why? Because it has not been called up yet by the file system. Alright? The buffer has not called that up yet by the file system. And can you change that? I don't know if it would even matter. Okay? Because this is the way that it writes. This whole chunk is called up, and you're expected to write code within this little certain area. And God forbid if you ever wanted to jump out to do something in another area, even by a small thing such as a couple bytes, even within a tolerance of say 16 bytes, you can't, because it hasn't called it up yet, and it won't call it up yet, and it won't call it up. If you need 16 more bytes, it's going to call up a whole 160 more bytes in order for you just to use 16, okay? Instead of Linux, which neatly comes back every so often and refreshes every bit of data that you have wrote, okay? Now that's that. That's a problem that I've noticed with DOS, okay? And leads me to the problems with Windows. And the reason why I connect Windows and DOS together is basically this. I don't know if you know or not, but in the Windows file system, there's still old Windows NT drivers. NT came out in like, what, 94? Okay? There's still old drivers. Why do you think when you go and install, do an install on Windows, sometimes, and a lot of times, especially on older machines, you always have a hang time, and you always seem to lose a driver. You always seem to lose the same damn AC97 Realtek audio driver. Okay? And the reason why is, for one, I think it skips it over, because I don't know how you can lose an audio driver. Okay? Which is not a problem with Linux at all. Alright? Because of the support in Linux. I think that there's a hang time that, one, Windows is so heavy and hogs down the system that the audio driver waits for a signal and only waits for say 10 seconds, and after 10 seconds the audio driver is not here, or it never was on the disk, even though you just reinstalled the same operating system that came with the computer, and the audio driver was working 1 hour before you started the install. But after you're done, it doesn't work anymore. Okay? It's not good how they do things. And like I said, they throw this whole bunch of crap at the wall, okay? And then you have to go back and unbloat it and shore it up and fix it up, alright? Now, I think too, this is why, and this could be far-fetched, but if you throw so much data at a wall, if you need RAM, this is from RAM, okay? It takes RAM to throw this stuff up for you to write to it. Okay. Now, if you have, say, this is a 16-bit, but if you have a 64-bit processor, like I showed you in the other tutorial, 64 bits gets thrown up at one time. Okay. Say this is a string of 64 bits. Okay. All this data is 64 bits long. Now, we do need 64 bits, okay? It can traffic more data for us, more positions, more everything else like that, blah blah blah. Okay, that's cool. It goes through our processor, blah blah blah. But not only does it go through our processor, it goes through our RAM, okay? And it gets thrown on the hard drive, okay? Now, instead of like a dog coming back and say lapping up what's put down and putting it down nice and easy and coming back and taking it again, okay, and putting it down what's easy, taking our next written bit of data and putting it down nice and flat and blah 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 like a Linux system does. This machine take this whole 64 bits, take this whole 64-bit byte, and throws the damn thing at the hard drive. Alright? That's what happens on a 64-bit machine, I believe. I ain't no scientist or no doctor or anything else like that. I'm not even going to school for computer science. Okay? But that's what happens. That's what I've noticed. And this is my theory. Okay? This is my theory. And this theory would definitely explain why we have computers, okay? Like I said, it takes so much RAM to throw 64 bits at a wall. It takes so much RAM to throw 16 bits at a wall too, okay? But in a 16-bit architecture, hey, that shit didn't matter. You know what I'm saying? In a 32-bit architecture, it really wasn't that bad, okay? But double that up to a 64-bit architecture, and the way that the file system writes, that is a massive amount of data to throw at a hard drive, to throw at a file format. Windows could improve their file format, and they did with NTFS, but it still is the same old shit, and you have to defrag the damn thing, because because you still need a comfortable medium with the old DOS drivers and the old way that DOS works. That's why DOS was still in the XP machines, okay, under the command prompt. You could run debug no problem in the command prompt on an XP machine, okay, and in a Vista machine, okay. But they started slimming it down ever since XP, or ever since 98. DOS has had limited functionality on the Windows machine. The command prompt has had limited functionality on the Windows machine ever since like 98, 95, okay. People who use Windows are not that smart when it comes down to command-orientated stuff, right or wrong. You know what I mean? And it's because that they're slowly degrading the command prompt and the capabilities of the command prompt and, like, say, debug features and everything else like that in the newer machines. Now, Windows 8, I've seen pictures and I've seen videos of Windows 8, but I tell you one thing, it's you guys are screwed. You guys are so screwed. You're not going to be able to get into anywhere in your operating system. You're not going to be able to learn anything in your operating system the way that it keeps going. Alright, so you throw 64 bits at a wall, okay? You throw 64 bits on outdated 30-year-old drivers, outdated 20-year-old drivers, outdated 20-year-old file format techniques. What do you think is going to happen when you throw 4 times the amount of data at something? Alright? You're going to have problems. You're going to have problems. You're going to get gaps and stuff like that, and you got defrag shit and blah blah blah, everything else like that. Now, like I said before, this is 64 bits of data that you're throwing at your hard drive, but it takes RAM to move that, right or wrong. Now, this could definitely explain why RAM now, why computers, why do new computers now with an i7 processor take 8 gigabytes of RAM? Why? 8 gigabytes of RAM. 20 years ago, 8 gigabytes of RAM was like unheard of. Like, you don't do that. That's for like a super, not a supercomputer, but that's for like something else. Alright? It's like a mathematician's thing, or you're like programming something or whatever like that. Why does it take so much energy to put this stuff out? And it's because the way that the Windows is the leading OS, okay? Windows sets the standard. Windows needs a lot of RAM to throw at the hard drive because they cannot improve the shit that they've had for 15 years without effectively breaking the system, okay? Everything in Windows, okay, has a static place, okay? Static versus dynamic, okay? Dynamic is like elastic, man. You take what you need, open it up, take some more. Static can only be one type of way, okay? And this is a perfect example of a static technique, okay? Compared to Linux, where it allocates certain amounts and with a refresh rate, and if you need more, it's going to allocate more and has no problem with throwing up, you know, a lot of bytes at a time. Everything in Windows is static, and it's because they're set on old principles still. If not, why would you have a driver? Why would you have a driver, an NT driver? Okay? Who uses NT anymore? What is it good for? Okay? It's there. It's not for compatibility. It definitely can't be for backwards compatibility. You gotta be kidding me. Especially with the way the Windows system works now. I mean, you can't even run things that used to be on a 95 machine or a 98 machine. So why would you still have an NT driver from like 94 or 95 or no 94? Why would you still have an NT driver? Okay? Because if they took it out, the system would break. Okay? Because what they did was they built on top of everything. Okay, the NT driver is still there, and it's supporting another driver or another thing that they improved on. Instead of taking the NT driver out and flushing the operating system clean, they just kept building on shit. They're just stacking shit up in a corner. Okay, stacking it up in a corner, and then they're pushing it as an OS. All right. And not only are they pushing it as an OS, they're throwing all that shit at your hard drive. Okay? And with the way that stuff is improving, when you throw all that at a hard drive, you need more energy to do that. That means you need more RAM to throw this stuff at your hard drive. Okay? We don't need that much RAM. Hey, 8 gigs is great. And I'm not a RAM Nazi. You know. I could care less how much RAM. You know? It doesn't matter to me how much RAM you can put on or whatever like that. That's great. You know what I mean? If you're trying to drive down prices of RAM, hey, put more RAM out. That's fine too. But I don't think that's the case. They need this to throw 64 bits of data up at your hard drive. Okay? 8 gigs of RAM. Think about that. 8 gigs of RAM. And if you're a Linux user, you know exactly what I'm saying, and it's laughable. It's laughable. I have my other tutorial been a Linux from scratch machine that stayed at 23 megabytes of RAM. It only took 23 megabytes to run that machine. Granted, it did not have a GUI. Okay? Puppy Linux uses approximately 123 megabytes of RAM. Alright? It's not the best OS in the world. It's not the sharpest, cheapest looking, you know, snazziest touch screen interface type of thing. But it only uses 23 megabytes of RAM for the whole operating system. It's completely efficient. Okay? TinyCore Linux uses 10 megabytes of RAM. TinyCore is something that I should say too is also an assembler based OS. Okay? Which is pretty daggone hot. Alright? And the reason why they got it so small was because a lot of their code was in assembler. And there is C, yes, but a lot of their code is in assembler. Alright, so they skipped, when I say dependencies, and how you don't need dependencies with assembler. What I'm saying is, in order for you to have a C program running on your machine, you must have C libraries. Okay? And the C libraries don't have to be a great length, or width, or depth, or size, but there must be C libraries on your machine. And the reason why I say Java sucks ass is Java has libraries, okay, that are just full of crap. Okay? They work on the same principles that Windows does, I think, to an extent. They don't really flush anything out. Okay? They keep stacking on old Java shit that's been there forever, okay? And they just keep building on it and building on it and building on it, okay? So it becomes bloated and it becomes known as a shitty OS because it's so heavy and you need all this stuff to run it. And that's okay, really, because guess what? We do have computers with 8 gigabytes of RAM, but it's not needed. You know what I mean? And I'm not like I said, I'm not a RAM Nazi. It's cool. RAM is cool. Fast speed is great. But efficiency means something, okay? And how fast, you might have 8 gigabytes of RAM, okay? And that's great. But how does your operating system work? You know? And if your operating system is not efficient at all, so that actually put 8 gigabytes of RAM on a Linux machine. Put 8 gigabytes of RAM on an Ubuntu machine. What do you think is going to happen? Your computer is going to scream. Okay? Scream for ice cream. Ice cream, please. Okay? That's what's going to happen on a Linux machine. Your computer is just going to be nuts. Alright? Why? Because Linux is efficient and is using every bit of those gigabytes in such a manner that in reality 8 gigabytes is what it is in an astronomical amount. But in reality with Windows, okay, you can't run Windows properly on a 4 gigabyte machine, let alone, oh Jesus, a 2 gigabyte machine. You have to be an idiot to buy a Windows machine with 2 gigabytes and think you're going to do some great stuff. It's going to be very hard for you. Okay? Because I think all the old trash, all the stuff that nobody wants to fix in the Windows side because they're so restrictive, all the old trash is still there and is still getting pushed up to the computer. So you might have 8 gigabyte, or you might have 2 gigabytes of RAM. Alright? Let's just cut it in half. You got a 1 gigabyte machine. Okay? For Windows. You might have 4 gigabytes of RAM, or 8 gigabytes of RAM on your Windows machine you just bought. But you're only going to be pushing 4 gigabytes. Because the other 4 gigabytes is pushing crap. Alright? Pushing stuff that no longer is needed, and they should have went in and cleaned it out and made it a nice operating system, okay? But they can't. Why can't they? Because they keep using the same old MS-DOS drivers, okay? The MS-DOS theory of how things are going to work, alright? And it doesn't happen. It doesn't happen that way, alright? Why is Linux so efficient? Well, there's people that pay attention to their code and they share information. And there's really, I kid you not, if there is 30 million users of Linux, okay? If there are 30 million users of Linux, and we are not stupid people, we know about our machines, we investigate our machines, you can have the simplest Linux user is 4 times a Windows user, alright? We know about things. Because we have to, because that's the way it's designed for us, right? That's the way the community is, okay? If we have a problem, what do? We end up going to a forum somewhere, and that forum tells us to type in some commands, or download this, or blah blah blah. It tells us an in-depth view of things, okay? Because we're smart users. Windows users are not that smart. Well, I'm sorry if you guys want to hate me, but on the average flat, hands down, you know we got it. Alright? So, and probably, it's not because of the nature of the Windows user. Not everybody wants to be a computer programmer. Not everybody cares about how their computer works. They just want it to work. Right or wrong? Yes. People have lives. Right or wrong? Yes. Not everybody wants to program their computer before they use it. They just want to do taxes, watch YouTube. That's it. Alright? But with the Linux community, people are really serious about what's going on, and they're enlightened about what's going on, okay? When you use Linux and you got Linux, you know you feel smart, right? You know that when you are on your Linux machine, you have a certain air about you that you are onto something. You are a smart person. You're a smarter person than you were when you first came in. Why? Because computers. First thing about computers when people think about computers is, okay, it's a computer. But as soon as they fail with a computer, they say, oh shit, it's a computer. You know, the computer's always supposed to be smarter than us. That's the way that they designed it, right? It's always supposed to be smarter than us. And that if any time we ever fail at anything, we are easily discouraged and we say, oh, it's a computer, I knew I couldn't get it, you know. And some people believe that lie. I don't, because I have the confidence, because I've been around in the Linux operating system, community, and environment to show me that I am smart and I can manipulate things. I can do things with this computer, okay? And it's not Windows users' fault that they basically, I'm going to say how it is, that they're at a lower intelligence, right? It's not because there's something actually wrong with these people or that they're dumb or whatever like that. No. It's because they stick to an operating system, okay, that really dumbs the shit out of them. It slows you down. Button clicking and everything else like that is great, okay? I use it for a pointer. But the button click, all you're doing is button clicking. All you're doing is button clicking. You're not learning anything, okay? Now you download some new program, right? Say if you download some program, you know, and then what you had to do is you got to memorize where the buttons are. You know what I mean? But what happens when a newer program comes out? You have to memorize where those buttons are. You have to fill in this box. You have to put this thing in this area. Can you see this? Yeah, I don't know. Alright? It's a remote desktop view or whatever like that. It's a SSH. So what? Alright? But you have to memorize where all these buttons do. Alright? And blah blah. And then you get a new program and you got to memorize what those buttons do, even though those buttons are something else that some other company's made or some other person's made. Alright? Just to pretty much confuse the shit out of you. Right? And you got a new box over here that you have to now enter this address into or something. Or you have to check the properties and make sure that the properties are correct. You know? But all you're doing is clicking buttons. You're not learning anything. You're learning how to use different buttons. And I think that that's not good. That's not good. It's better to know how to do something than actually, for one, go hunt around the world for one, or one pay, what was it, 60, what was it? It was something dumb. Like a word processor was like 65 bucks for Windows or some stupid shit like that. It just made no sense at all. I mean, and it was the same damn word processor that already's been out forever, right? The only thing it did was move the buttons around and said it was newer and had more virus protection. You know? It makes no sense. It makes no sense. If you want to go ahead and do some type of, say, internet routing or whatever like that. Oh my God, can I even say IP config in this daggone thing? Config. Of course not. Okay. If you want to do some type of internet routing, what do you do first? Alright, if you're a Linux user, you know what to type in, you know how to look at stuff and interpret stuff, okay? But if you're a Windows user, then you have to go find Bill Gates' new router program, you know, and then you go through Internet Explorer and get all kind of pop-ups and all kind of virus protection craps and all kind of things, alright? And the only thing you're doing is looking for something that you can stick more stuff in for boxes, and it's because they say it's better. They say it's more protected. They say it's more secure. You don't know that, alright? And it's just a remake of the old freaking show. You're going back seeing the same old movie and you're paying more and more every time you go. Alright? And it's not your fault. It's because of the way that your operating system works. It's because of the ideals behind the people who created your operating system. They want to keep you stupid so they can keep you coming back for money. And hey, if you got money, that's fine. If you don't have money, that sucks. You know? It really sucks. So, that's my theory on why we have so much RAM. and having so much RAM is not really a bad problem. Getting faster is great, okay? That's great. Speed is good, okay? The ability to calculate different things faster is good, okay? FYI, Cray is a supercomputer company, right? Okay, great. They submerge their processors in like liquid, probably liquid helium by now, okay, which is like so sub-zero, okay. I don't know how deep it is. Can we say negative 413 degrees or so? All right, but it's like that cold, okay. Why did they have it that cold? All right, because their processors, unlike our processors, unlike this particular processor, say if you have a processor even now, you'll notice C2, RAM is going up, hard drive space goes up, okay? You can get it 1 terabyte now for like $100, okay? And back in the 80s, back in the early 90s, you were going to pay like $1,000 or $10,000 for a 1 terabyte, okay? Um, RAM is going up, 8 gigabytes of RAM. So RAM is going up compared to 10 years ago when 512 was like a standard. 512 megs was a standard amount of RAM, okay, that computers shipped with, okay. RAM is going up, hard drive space is going up, okay. That's good. We need that. But how good is it if your old Windows takes half of that? Minus you 1/2. How good is it? It's not good. You're still using a 4 gig machine. Okay? That's that. And it all has to deal with the file format. It has to deal, you know, if you want to think philosophical about it, it has to deal with their incompetence. And you question, where's your data going? You know, with something like that. How does Windows actually know you don't have a virus program? How does Windows actually know things? Why is Windows being questioned for selling your data? Okay? Why does that happen? Right? There's no conspiracy about it. Okay? When you get the Windows update, how does it know if you have a cracked Windows or an authentic Windows or not? When you use a bootloader, or if you put in another different code, how does it know? Alright? So, without saying Big Brother's watching you, Big Brother's always watching you, right? And that's what you get for listening to a guy who's sitting at a black screen all the time on a terminal. Those terminal guys are nuts. I'm not nuts, but the issue, there is an issue with the way that it processes, the way that DOS is, the way that Windows is, and everything else like that. And it's not productive. It's just not productive. 200 bytes is not with a 30 byte tolerance. 30 byte tolerance is like not a productive thing at all, okay? And then to get a stupid ass error, just a flat error message, that could mean like, you know, hey, you forgot to throw in a comma, okay? It's not specific at all. These are the type of problems you will run into when learning assembly on DOS, okay? And I'm done venting. Sorry you had to hear all that. Have a great day. Kill the rabbit. Don't nobody be so dumb to do that. Later on.